Capital FM, fresh hits for Uganda. DJ Will.
Good evening, everyone.
Good evening, teacher.
We have an example here. This number is in understanding mechanics. So it says a tennis ball, no, my spelling of tennis is wrong, is served horizontally with the initial speed of 21 meters per second from a height of 2.8 meters. By what distance does the ball clear the net? 1 meter high, situated 12 meters horizontally from the server. I think most of us have seen tennis. You know what tennis looks like. Those two ladies of USA called Serena Williams and Vanessa Williams, that's the game they play that made them famous. Now, if I look at a serve of the ball, who is at a height of 2.8 meters, he serves this ball horizontally. Then this ball is going to travel like this. To come to the ground. But as this ball is going, it is going to clear a net. This is where the net is. The net is 1 meter high. And it is 12 meters away from the server. So the height where the ball has been served is 2.8. Now, when you look at this ball, if the ball is clearing the net from here, then at this line, there's some distance they're asking for. They're asking for this distance X. Let me call it, okay, Y. Or let me call it H. The distance above the net by which the ball clears the net. Okay? So at this point, the ball will have traveled a distance, let me call it Y1, which is from there up to here. So if it has covered Y1, if I find Y1, then I can see that Y1 plus the height H plus the 1 meter all should be equal to 2.8 meters. Because the total height was 2.8. So it means that if I'm looking for H, I'll get 2.8 minus 1 plus Y1. So according to this illustration, they gave us x. And remember, x is got from ut cos of theta. But if the angle of projection is 0, like this one, when it's projected horizontally, then theta is 0. So for that reason, x is always equal to ut. So we can find the time taken to cover the 12 meters, which time will be x over u, which will give us 12 divided by, the speed was 21. So 12 divided by 21 will give us the time. What time is that on the calculator?
.57.
Okay, which is 4 over 7, eh? All right?
Yes.
Now, having realized that time can help us find y1. Remember, the particle is going below the point of projection. It's given by ut sine of theta minus gt squared over 2. But because theta is 0, sine of 0 is equal to 0. So we remain with negative y1 is equal to negative gt squared over 2. Then this becomes positive. So y1 can be got from 9.8 divided by 2 times 4 out of 7. The whole of it what? Squared. Press your calculator and get y1.
.1.6.
1.6 meters. So if I want to get the height with which the ball cleared the net, then it will be h is equal to 2.8 minus 1 plus 1.6. And the answer is 0.2 meters. So that would be the height with which the ball cleared the net. Sometimes if they say it just clears the net, when they say just clears the net, it means it is passing at the height of the net. When they say just clears your hair, it is at the height of your hair. Okay? Okay, let's have other groups. Unless if someone has a question on this now. Yes, please.
Yeah, for me, the problem is that when we're starting these other lessons, I wasn't around. It's just someone that told me that we had a lesson tonight, so I'm confused.
We are just doing numbers. You are not around during the day. We are just doing numbers. We finished the definitions way back. So just wait for you are just doing numbers. But I can give you the video.
Okay. Yes, teacher.
So you keep reminding, I will upload it or you keep reminding me.
Okay, sir.
So we have example 2 here. It says 2 particles are projected simultaneously from 2 points, A and B, on a level ground with a distance of 150 meters apart. The first particle, that is projected vertically upwards from A. Vertical upwards means it's projected straight up without an angle. Until they tell you this is projected at some angle, but if it says just projected vertical upwards, it means it's projected straight, perpendicular to the ground, with an initial speed of u meters per second. Then the second particle is projected from B towards A with an angle of projection alpha. If the particles collide when they are both at their greatest height, prove that tan alpha is u squared over 150g. So you first sketch the model. So the model will look like this. I can have this page. This is the level ground where we have A and B. So A is projected vertically upwards. This is what I meant by vertical projection, with a speed u. Then B, the particle is projected at an angle alpha, so that this particle moves and then comes and it collides. So this one has been projected with a speed of what? The second particle is projected towards A with this A. We don't know its speed, so we can assume its speed is V. It wasn't mentioned. Now they are colliding both at greatest what? Heights. So that means this is capital H, their maximum height. Now, if you've identified that that is maximum height, we have also this distance is 100 what? 50 meters. So because this is 150 meters, when you consider B, from X is equal to UT cos alpha, we shall have this equal to 100 what? 50. But this is U, let me call it U prime. So that finally for V it becomes V T cos alpha is equal to 100 what? 50. But also at maximum height, still for B, time to reach maximum height is U sine of alpha over G. I'm calling it U prime because we have U already in A. U prime is the velocity of at B. So we shall have V sine of alpha over G, whereby I can decide to make V the subject, or I can equate the time here in Roman 1 and the time here in Roman 2. Or I just take the time there by putting 2 into 1. So we shall have V times V sine of alpha over G times cos of alpha is equal to 150. So when you do that, you can clearly see that we have
JD isn't.
Pardon? V squared.
On this side.
We have V squared is equal to, okay, you want me to do it again here? Okay, when I substitute for V, I'll have V squared sine alpha cos alpha over G is equal to 150. Then for A, at A, time to reach maximum height is U squared over, is U over G. But because they are projected simultaneously, the time is the same. So the time is the same as V sine alpha over G. You know what this means? It means I can lose the G with this G. Then I can consequently say that V sine of alpha is equal to U. Or V alone is equal to U over sine what? Alpha. Now bring it up here where we have seen V squared sine of alpha cos of alpha over G is equal to 150. When I put here V squared, I'll get U squared over sine squared alpha times sine alpha times cos alpha over G is equal to 150. I can divide by sine alpha, I lose one sine. Then it will give me U squared over G tan of alpha is equal to 150. So finally, tan of alpha is U squared over 150G. Hence the solution. The proofs in most cases become a little bit technical, and learners find a challenge in how to go about them. Now, like you've seen, they need a lot of trigonometry. So the trig you cover the other side in paper 1, because this is called applied math, you have to be in position to apply the trigonometrical math in such situations. We have any questions?
Excuse me, sir.
Yes, please.
Excuse me, sir.
Yeah?
May you please go through one more? May you please let me go through one more?
One more time.
From the side. Yeah.
Okay. Now, we had two particles projected simultaneously. One was projected vertically upwards, while the other was projected at an angle so that they could meet. It's projected at an angle to go to the other one so that they can collide. So when they collide, what happens is they are colliding at the same height, which height they said they were all both at maximum height, which we have seen as h. So when I considered B first, I assumed B had a velocity of v. So that if I get the horizontal displacement of v, it would be x times u prime t cos alpha, because that's the general equation for horizontal displacement. X is normally ut cos theta or cos alpha, but I'm assuming this u prime is the v. Then I substituted for the v, t is still unknown, cos alpha is unknown, then I have the x as 150. Then I also considered another condition, that if B reaches maximum height, what time does it take? Time to travel to maximum height in trigonometry is defined by U sine alpha over G. And that's how I got this equation. But the U is not the U because we have not said we should use U. Reason being A is projected at U. So we are using U prime, which is standing in for V. So that's why this is V. Then sine alpha over G. But because they are projected at the same time or simultaneously, the time for A is equal to the time for B. And for that reason, find the time here. For vertical projection, when you go to V is equal to U minus GT. When the particle is projected vertically upwards at maximum height, T is 0. V is 0. So time would give you U out of G. That's how I came up with this second equation here for A. Then, but before I went for A, I got this T and I substituted it here to arrive at this step and to give us this equation. Let me call it equation star. Now, because the time for A is U over G, which is the same time for B, which is V sine alpha over G, I equated the two and I made V the subject, which is U out of sine alpha. Then I went and substituted V here in V squared, which gives us U squared over sine squared alpha, which is this step, times this one, which was there already. Then you divide by sine, you keep one sine down, This cos can come back down. It becomes a tan. Because if you have u squared over sine of alpha, and the cos is up over g, it's the same as bringing this cos down. It's the same as saying u squared over sine alpha over cos alpha. That's how this became tan. Then you make tan the subject and you get the answer. Yep.
Okay. Thank you.
Teacher. Excuse me, teacher.
Yes, please.
Teacher, at first you had said that time due to the condition that these bodies were fired were projected simultaneously, which means at the same time we have equated equation 1 and 2, right? Yes. So
we have equated them because the times are the same.
Yes. Now, how about this? I'm sorry, but I'm not understanding how this other time of u squared over g comes about. If you could please
It wasn't u squared.
repeat.
This is not squared. It wasn't squared, eh? It is just a mere u. I had written a square there, then I rubbed it. That is the time to reach maximum height for A, this one. Then this is the time to reach maximum height for
Just
B.
for
A.
Okay, yes.
You're getting it, eh?
I understand.
Yeah, so when you equate those two times, you can eliminate the V by making V the what? The subject.
The subject. Okay. Thank you very much.
You're welcome. Okay, we have another number here. A ball is being projected so as to just clears. I told you when they say just clears, it means it is passing at the same height as the body it is clearing. So it just clears two walls, meaning the ball is at the height of the wall in that sense. The first of height, small a, at a distance small b, and the second one of height small b and the distance small a away from the point of projection. Show that the range of the horizontal plane is given by that. Quite an interesting number. By the way, have you covered factor formula in trigonometry? Today we don't have graphs.
Yes, sir.
You have covered it?
Yes, sir.
Okay.
Yes.
So you guys are going to go to school when you're bad. You are ready to go to senior 6, I can see. Whoever has been serious is ready for senior 6. They are saying we should not give exams, but I don't know whether schools will agree to just promote you. Might be hard, so being ready is the best option. So I'm assuming we are projecting the board at an angle, alpha, at a speed u. The first wall is of height small a, with a distance b away. The second wall is of height small b, with a distance of a away. Now, to start with, the question wants us to find the range. But before you can find the range, you know range is given by which formula? R is u squared sine 2 alpha over g. Because I'm given vertical and horizontal displacements, remember the best equation for those items is the equation of the what? The trajectory. Hope we all recall this equation. So for case 1, the first wall, the height is a, the horizontal distance is b, minus g, b squared over 2u squared into 1 plus tan squared alpha. Then for the second wall, the height is b, is equal to the horizontal distance, which is a, tan alpha minus ga squared into 1 plus tan squared alpha over 2u squared. This is equation 2. This is equation 1. Let me rub off this part. Now, with that sense, what is going to happen is we shall have, having realized that, we can clearly see that if I have, for the first one, b tan of alpha minus a is equal to g b squared over 2u squared sec squared alpha. I have condensed this to sec, and then I have moved it to the left-hand side. I've moved it this way. Then I've brought this one this way. Let me call this equation star 1. Then for this one, I'll have a tan of alpha minus b is equal to ga squared sec squared alpha over 2u squared. This is star 2. Now, about solving, because we are now just solving trigonometry, we are solving just equations of trajectories. I mean, equations of trajectories. You solve them anyhow. You solve simultaneously, you solve by elimination, you solve by division, you solve by making the subject, by substitution method, by elimination method, you solve using the skills of simultaneous equations. It's just that here we have advanced them, okay? Now, with this reason, we are good to go and divide. If I divide star by star 2, this is going to be b tan alpha minus a over a tan alpha minus b is going to be equal to b squared over a squared. I don't know that you can see me. Can you see me or you can see the expression? Let me pause for a while for some questions there. Have people seen what has happened?
Yes, teacher.
The rest, are you seeing what is taking place?
Not.
That's what I want to hear. If there's any plan, any step I move ahead and you don't see it, please allow me take you through it. Okay. Now this was like this. Let me remove this part. Okay. It was supposed to be GB squared sec squared what? Alpha over 2U squared divided by GS squared over 2U squared sec squared what? Now by this time you should be experts at division. I divide the G by the G. 2U squared, 2U squared. Sec squared, sec squared. I remain with only B squared over A squared. Is it better now?
Yes, teacher.
Okay, that is better. We shall have B tan alpha minus A over A tan alpha minus B is equal to B squared over A squared. When you cross multiply, we shall have A squared B tan alpha minus A cubed is equal to B squared A tan alpha minus B cubed, giving me A cubed minus B cubed is equal to A squared B minus B squared A of tan alpha. Someone is in my chat. Let me check him out. Which eye do you use to apply all the mathematics? Stephen Mogera, what are you trying to say? Which eye do I use? What do you mean? Which eye do what's your point? Come on. Like I've said, it's all about algebra. You should find means of solving these simultaneous equations in any way you want. You can, in your free time, make sec squared the subject, or make sec squared with the G and over 2U squared the subject, and then equate the two. Or you substitute them, or you subtract them, whatever you want. We are solving simultaneous. It's just that we are solving advanced numbers, not the O-level numbers. Okay, I need your eyes open here. All right? But how can you open them? This is how you're going to open them. This is A cubed. Now let me remind you this. A cubed minus B cubed is equal to A plus B. Sorry, is equal to A minus B. Let me first erase this. Is equal to A minus B of A squared plus AB plus B squared. This is got from Pascal's triangle. If you cannot see it now, you go and expand in your free time. You know, this is applied math, so we are applying the pure math you've learned. And I trust very well that you've covered Pascal's triangle. Okay, so with this illustration, we can have A minus B into A squared plus AB plus B squared is equal to AB into what have I done? Into A minus B. Of tan alpha. I think here you can see that the A minus B has died. This can be divided by this one. If those two are divided together, we get 1. Then finally tan alpha will be a squared plus ab plus b squared all divided by ab. Now, this is not the question. That's not the proof the question asked. The question asked for range. But we have got tan what? Alpha. Okay, I trust you must have finished this number way back. So let me erase it and finalize this example. Then we have one more last one in proofs. Then we shall remain with all the numbers in projectiles to solve by ourselves, exclusive of the teacher. Okay, more action. This number, if it is set, needs like 12 marks or 6 marks. Now remember, range is u squared times 2 sine alpha cos alpha over what? Now we need to introduce what we call, we need to bring in tan. Your trig machines. Who can suggest what we can do to bring in tan? Someone suggest something? Let me see who is your trig machine. These numbers help us, teach us how to think. Yes.
Teacher?
Yes, please.
We divide by cos on both sides.
We divide
by cos on both sides.
We divide by cos on both sides. If we divide by cos on both sides or up and down?
Both sides of the equal sign.
Then this way you have r over cos, which is sec. Then the other side you'll have what? You'll have sine only without tan. We want to bring in tan. Ladies, think.
Teacher?
Yes, please.
Like divide
by
cos
what? Yeah? Divide by cos?
We multiply cos of introducing a useful.
A useful one for what?
Introducing a useful one whereby we are for turning that sign into.
Whereby we are going to do what?
Tan.
How do you introduce the useful one?
We multiply by cos over.
Multiply by cos up and down.
Multiplying by cos over.
Cos over what?
Yes.
Cos is wrong. Another one. Now, these proofs are found in Humphrey. So the Humphrey book, you have it on the group. Even it is there on my Google Class. You should go and try out more proofs there. I'm going to do another last number, which is coming from Bostock. It's also a proof. Now, guys had an idea of cos, but if you want to introduce tan, we divide by cos squared. So divide everything by cos what? Squared alpha over g over cos squared what? So that this cos up can be lost. We remain with one cos. When you lose that cos up, what is going to happen? We shall have r is equal to 2u squared times tan of alpha over G sec squared alpha. Do you see that this is the same as 2u squared tan alpha, or is over G into 1 plus tan squared alpha. Are we together? Have you seen that? If I bring in more action?
Yes.
Yes.
Okay.
Yeah.
Nice to hear the ladies in bulk. Okay, I was worried that they may be scared or I don't know. But nice to hear that you're okay. Now, can I substitute for tan? When I substitute for tan, see the action. We are going to have an action of R is going to give us twice. Let me say U. No, I didn't. Okay. Before I go further, look here, open your eyes widely. This is the same as tan alpha is over G sec squared alpha over 2u squared. Can I hear a yes?
No.
Okay. Another one. Do I hear a yes or a no?
Teacher, no.
Okay, I've moved from here, girls, up to here. How about that? Is that a yes? I've brought this 2u squared down. When I bring it down, it becomes a denominator. If it was a numerator. Yeah?
Yes.
Teacher, why do you do
Okay, it's the same as doing this. If I have A over B, it's the same as 1 over B over A. Reverse order. Does that now make sense?
Yes, teacher.
Okay, so should I proceed? The boys, are you enjoying? The boys, are you already enjoying so that I proceed without any hesitation?
Yes.
I thought you had lost data. Okay, let me go on. So this is going to give me A squared plus AB plus B squared over AB. All is over. Eyes open wider. G sec squared alpha over 2u squared is here in one of these two. Which one do you want to use? Star 1, star 2. Which one should I use? Star 1 or star 2?
1.
1. Okay, look here. From 1, B tan alpha minus A over B squared is actually equal to G sec squared alpha over 2u squared. Do you agree? Do I hear yes? I just move only the B, okay? I just move only this one. This way, so that I create this, that to match this. Okay. Boys, you're too quiet, I'm worried. So we shall have over B tan alpha.
First repeat for me that.
Yeah. I repeat how I've made the G sec squared over 2u squared the subject, eh?
Yes.
Okay. I've divided this B squared by bringing it this way down. On both what? Sides. Okay? Then the B squared died off. Then I made what you wanted the subject. All right? Does that make sense now?
Yes.
Okay. Now, substitute for tan again here. But before that, look here. There is a b here. I can lose one b with this one straight away. So this will give me a squared plus ab plus b squared. With these numbers, even if you do two numbers in a lesson, it is okay. Over a divided by eyes open wider b into a squared plus ab plus b squared divided by ab minus a, all is divided by b. I lose this b. I lose this b with this one. Are we together? This a is going to go and multiply this one. What will it realize? It will realize a squared plus ab plus b squared, all is over a. The whole of it is over a squared plus ab plus b squared minus a squared. The whole of this is now divided by b, by a, b. This b is going to die with, this a is going to die with this one by division. So finally I will get a squared plus ab plus b squared divided by, have you seen the subtraction of the a's squared? There is this a squared and this one. You can subtract them off and you get a 0. Then you remain with b, a plus b, bracket, outside there is a b, but down here there is a b. I have factorized out this b so that I can finally divide off this b and I conclude my proof. This b vamooshes with this b, and finally our equation of the range has showed up, which is a squared plus ab plus b squared divided by a plus b. And here we go, hence the proof. Okay, it's quite a page. How are we doing, guys? Should we go for one more? Because this is the last lesson I'm having for projectiles. I wanted to have one more. But before one more, of course, if there's a question or a concern, please you raise it.
Teacher?
Yes, please.
Teacher, please pardon on the meaning of
what? Meaning of what?
it just clears, like the ball is projected so as it just clears.
It means if it is clearing, for example, it's a goal post, yeah, with a net. And they tell you a ball is kicked and just clears the post. If it just clears the post, it means the ball was passing at the height of the post. So where the high ball is the height of the what? Of the post. If they say the ball just clears your head, it means it is at the height of your hair. So it is at the same distance as your hair from the ground. All right? That is what it means. So whenever they say it just clears, then it is at the same height with whatever it is clearing. It is not knocking it. But if it is clearing it, for example, today I don't have what? I don't know that you can see this pen. Okay, look at this phone. If it just clears this phone, then it is going to pass just on the head of the phone as it flaps off, flies over. But it is not colliding with it. So we assume it is at the same height as the phone from the ground. Okay, have that down. You have one last example. So on Monday night, that is demand at 8 p.m. We should introduce equilibrium